Good morning, students. So let us continue with the evaluation of integral by using beta function. So we have covered four types of integral. Already I shared my screen. So in the first lecture, I think in the examples on beta functions, first beta function, here I covered. So type 1, depending on the nature of integrand, you have to decide what will be the substitution. This is a type 1, this is a type 2, this is a type 3, and yesterday here we have seen that example based on that trigonometric terms, so that we consider as a type 4. Now let's continue with the next type. If the next type, then how to evaluate the integral. So continue with the next one. Suppose you are using definition of beta either in the algebraic or trigonometric any. So the next one, type 5. Type 5 and example number 1. So that I will consider as a example 1. So prove that the integral, now see the nature of integral is given as integral from a to b. Limits are given some finite number. Limits are given some finite number a to b, and that integrand is given by the two factor. One is x minus a raised to some power m, suppose, and second one is b minus x raised to n into dx. So one thing you can notice, the two factors are given in such a way that one factor is the variable, or we can say x minus lower limit, and other one is upper limit minus x, and this answer comes as b minus a raised to m plus n plus 1 into beta of m plus 1 and n plus 1. Okay, so let us continue. Now these are the standard types. First I am taking one standard example, and one particular you have to remember the substitution. If you know the substitution, if you recall the substitution, then you are through. You can complete the example easily. So first, suppose let the given integral I is equal to integral a to b x minus a raised to m into b minus x raised to n dx. So again I am telling, these are the standard examples. You have to recall the substitution. So what is the substitution? You have to put, this is a way to remember the substitution. This is not an actual substitution, and from this we reduce that for x. One factor is given as x minus a. X minus lower limit is equal to subtraction of both. That means upper limit minus lower limit, b minus a into t. This is a way to identify the substitution, or the same thing you can write, and this we can treat as actual substitution. X is equal to this a, I will transfer to the right side, that minus become plus. This is a plus a plus b minus a into t. So remember, either you can use first while finding the limits as a substitution, or second. Actually our substitution is x in terms of t, that is the second part. So if this x is your substitution, then what is dx? What is dx? Differentiate both sides. Dx is given by, first term is constant, that is a, derivative is 0. For the second term you have to write b minus a as it is, and differentiation of t is dt. Now start with the limits. Given limits for x, it is given as a 0, sorry, a as a lower limit, b as a upper limit. So can anyone help? Now let me know value of t when x is equal to a. When you substitute x is equal to
0.
a, yes, very good. So when you substitute this, you can use to substitute x is equal to a. When you substitute x is equal to a minus a, it will comes as a 0. Okay, lower limit is 0, that is required for beta. Now when you substitute x is equal to b, in that case what you will get?
T is equal to 1.
T is equal to 1. So that are the limits for the beta function. So here I will make a table if required. So these are the new limits. Therefore that integral, before writing integral, I will calculate, consider the two factors. Already x minus a factor you have calculated. Now I will calculate b minus x. So b minus, you have to use bracket. Now value of x from this second term, this one, value of x. So which is given by a plus b minus a into t. And if this you simplify, I will simplify the bracket. B minus a, outside minus is there, that's why that term will get minus b minus a into t. Now one thing you tell, if I put bracket here, whether the meaning changes? Say yes or no only. If I put a bracket, whether the meaning changes? Yes or no? Anyone? I don't have second screen. I will not take the name. Whether the meaning changes? If I put bracket?
No, sir.
No. Okay. So why I am putting the bracket? Because now I will treat these as a two terms, and from that two terms I will take b minus a as a common. Okay, these two terms. So what is the first term? The first term is b minus a only. Second term is b minus a into t. Now from these two terms I will take b minus a. Remember, our target is to obtain the kernel. So if I take b minus a as a common, what is the remaining term for the first? Everything you are taking outside. What is the remaining term? Quickly, those who don't have any disturbance, they can give the answer. If I taking b minus a as outside, what is the term?
1 minus t.
It is 1 minus
1 minus t.
1 minus t. Okay, very good. So that's why now I will write the integral. Then the given integral I can be written as new limits of the integral from 0 to 1, new limits from 0 to 1. Now x minus a factor already we are having. So that factor is given by b minus a into t, its whole raised to, what is the power? M. Now second factor also you have simplified, and that you are written in the multiplied form, which is given by b minus a into 1 minus t, that whole bracket raised to n, I think. And value of dx here we have calculated. So value of dx is b minus a into dt. Now what is the next simplification? Anyone? Now I don't need upper steps, that's why I will scroll down. So what I will do, this b minus a, this b minus a, and this b minus a, that is a constant term, and by linearity property that term I will take outside the integral. So can anyone tell what will be the power? B minus a raised to
M plus n plus 1.
m plus n plus 1. Okay, integral remaining 0 to 1, remaining is t raised to m into 1 minus t raised to n and dt. I think second integral defines a beta. For your understanding, once again I will write a beta of mn. So can anyone narrate what is the definition of beta? 0 to 1, what I have to write?
X raised to m minus 1.
Okay, x raised to m minus 1 into
1
minus x raised to n minus 1 dx. And one more thing, definite integrals are independent of the parameter. That same integral I will write t raised to m minus 1 into 1 minus t raised to n minus 1 dt. Okay, so to convert this to the beta form you have to make adjustment. That's why here I will write plus 1 minus 1 plus 1 minus 1. So this can be written as further by using the definition p minus a raised to m plus n plus 1. So yes, what are the parameters? What are the parameters? I am highlighting that. What is the
M plus 1, M plus 1.
m plus 1 and n plus 1. Okay, and I think that is the required answer. M plus 1 and n plus 1, and that is the required answer. If required, I will scroll little bit up. Now you can see that is the required answer. Okay, so one particular example. If any doubts, I will take the doubts. Otherwise, I will continue with the particular example. Second example. Meanwhile, if you have doubt, you can ask. Second one. Evaluate. I will take particular example on this. Evaluate integral 3 to 7 integral 3 to 7 fourth root of x minus lower limit, that is 3, upper limit minus x, that everything as a fourth root, into dx. Okay, now I will call this integral as a I. So let I is equal to integral from 3 to 7 fourth root of x minus 3 into 7 minus x, and integral with respect to x. So fourth root I will write in terms of the power. What I have to write then? X minus 3 raised to, suppose I want to write as a power, and 7 minus x raised to, suppose I have to write the power. What is the power then? Quickly.
1 by 4.
1 by 4, correct. 1 by 4. Okay, so again that substitution part I will write to the right side. We'll manage here only. Now, can anyone tell the substitution? Go with the standard that you have to remember. X minus a, what is the value of a? X minus a, what is the value of a? I am highlighting.
X minus 3 equals to
X minus 3 is equal to b minus a, that b minus a is 7 minus 3 into t, or x is equal to this minus 3 I will write to the right side, that become plus, and 7 minus 3 is 4. So that's why you are getting that substitution as x is equal to 3 plus 4t. That's why dx is given by 4 times dt. Also I will calculate the second factor. 7 minus x is given by 7 minus into bracket 3 minus 4t. So that you can simplify 7 minus 3 and minus something wrong. This is plus here. This is plus, this is minus. So further it can be written as 7 minus 3 as a 4 minus 4t. So 4 can be taken outside. It is 1 minus t. Now the limits part. Anyone tell me the limits? What are the given limits? Given limits, x is equal to 3, x is equal to 7. What are the limits for t? So you can use this substitution or any there. If you substitute x is equal to 3, obviously t is
2.
no. X is equal to 3. If you substitute, what happen? So because of this factor, remember na, 3 minus 3, 0. That is t is 0. If you substitute 7 minus 3 get cancelled. 1. Okay, just a minute. That upper limit as a 1. So these are the new limits for variable t. Okay, these are the new limits. Therefore, thus that integral I is equal to new limits 0 to 1 x minus 3, that is 4t. Can I write it as a 4t? From where I am writing? I will highlight. If suppose if you are simplifying this term, x minus 3 is equal to, is it clear? And second one is 7 minus x is 4 into bracket 1 minus t, that whole bracket raised to 1 by 4, and dx is given by 4 times dt. Now from this I will take 4 as a common. 4 as a common. What are the powers? 4 raised to 1 by 4 plus 1 by 4 plus 1 into remaining integral is 0 to 1 t raised to 1 by 4 into 1 by t raised to 1 by 4, both coming as a 1 by 4 only. And I think by definition this I will write outside term. It is 2 by 4. 2 by 4 means 1 by 2 plus 1. What is it? 3 by 2. Now here you have to make adjustment. I will write plus 1 minus 1 plus 1 minus 1. I think both parameter will get same here. What is that parameter? Yes, anyone? Beta of 3 by 4 and 3 by 4. Is it right? Make me correct if I am wrong. Okay, 4 into 4 raised to 1 by 2. This I will write, I will split. And again, using relation between beta and gamma mn. So beta of mn is given by gamma m into gamma n divided by gamma of m plus n, and further using the property of gamma function. So that's why it can be simplified as gamma of 3 by 4 divided by gamma of 6 by 4. 6 by 4 means 3 by 2. If you don't have disturbance, you can keep unmute. Okay, 4 raised to 1 by 2. So gamma 1 by 3, it is not possible to simplify. That's why I will write gamma 3 by 4. Because if you subtract na minus 1, it comes as a negative. So this further I will simplify as a 1/2 into gamma 1/2. Which property I am using? Gamma of n plus 1 is n gamma n. So therefore, it can be written as, yes, final answer anyone can tell? Eight. Well, from where I am writing 8? This 4 and this 1 by 2, that comes as a 8, and these two terms I will write together. What is this 2 raised to 4 raised to 1 by 2?
That should be beta.
Something is wrong?
Sir, it should be beta of 5 by 4.
Yeah. Yes. 5 by 4. I made mistake here. Okay. So up to this I will rub everything, and once again I will continue this one. Okay. So it can be written as, this can be written as, so 4 raised to 2 by 4 means 1 by 2 plus 1. Is it okay? And this is beta of 5 by 4 and 5 by 4. So further, this can be written as 4 into 4 raised to 1 by 2. Okay. 4 into 4 raised to 1 by 2. Gamma of 5 by 4, gamma of 5 by 4 divided by gamma of 5 by 4 plus 5 by 4. That comes as a 10 by 4. 10 by 4 means 5 by 2. Is it okay? That's why meanwhile I'm asking. That's if you give the proper feedback, in that case it will be help me. So 4 raised to 1 by 2 means square root of 4, and square root of 4 is 1 by 2. So gamma 5 by 4, by using this property, it can be written as 1 by 4 into gamma of 1 by 4, 1 by 4 into gamma of 1 by 4, and this 5 by 2 can be simplified as 3 by 2, 1 by 2, 3 by 2, 1 by 2 into gamma of 1 by 2. Now further see the terms which get cancelled, that I will write first. This 4 and this 1 by 4 get cancelled. Right? Right? Now again, this 2 and this 1 by 4 is nothing but 2. Now what will be the final answer? It is 2 divided by 3 into, means again this 1 2 cancel with this 1 2, only 1 2 is remaining, and in the denominator 3 is remaining. 2 by 3 into, okay, gamma 1 by 4 and gamma 1 by 4. I will write it as a gamma 1 by 4, its bracket square, gamma 1 by 4 its bracket square, and gamma 1/2 is root pi. Verify it. Can anyone confirm me? Your calculations are same?
Yes, sir. Yes, sir.
Okay, fine. So I is given by
Yes, sir.
2 by 3 gamma 1 by 4 into root pi. I think there will be no doubt. One example you can take as a homework. This is the third one similar to this. So take down the statement, evaluate, then immediately I will shift to the next. Evaluate integral 5 to 6. What happening? I have to off. 5 to 6 x minus 5 raised to 5 and 6 minus x raised to 6. You complete it as a homework. Only one example you can practice. Now next one, type 4 or 5 I have completed. This is type 5. Now the next one is a type 6, and that we treat as a third definition of beta function. So that is a type 3, type 6, not 3, type 3, and that we reduce to the third definition of beta, and that I will consider as the fourth example. So prove that integral 0 to infinity. So today I will try to complete this unit. Integral 0 to infinity x raised to m minus 1 divided by a plus bx raised to m plus n dx is given by 1 upon a raised to n, we will verify it, b raised to m into beta of mn. Okay, so for all these types you have to remember the substitution properly. If substitution you know, then easily you can evaluate. So first step, I will call the given integral as the I. So let I is equal to integral 0 to infinity x raised to m minus 1 divided by a plus bx raised to m plus n into dx. So when the integrand is given in the rational form, x raised to upon some a plus bx, so this we treat as a third definition. One definition we have studied 0 to 1 x raised to m minus 1 and 1 minus x factor, and one second definition we have studied in terms of trigonometric terms, and this is the third. Now again remember, the substitution is a standard one. So so what you have to substitute in this integral? This term. What I have highlighted, it is a bx. So put bx is equal to a. What is a constant term here? A, that is at divided by 1 minus t. This is a way to remember the substitution, and from this you can write substitution for x. So x can be written as a divided by b into t divided by 1 minus t. Okay, so this is your substitution. Either you can use first one or the second one. So I will give 1 minute. Anyone can compute dx and tell me the answer. I will pause the video. I will take a break 1 minute. So try to calculate dx and tell me. Once again, so can you tell dx value once again? Repeat. Yeah.
A by b,
yes,
into 1 by 1 minus t square into dt.
Okay, very good. What you did for the right side, I think you have to use the quotient rule. Remember, for first example only I will calculate that. So if you differentiate dx here, differentiate both sides, this dx is equal to this a by b outside term remains as it is. Now here I have to use the quotient rule. So denominator as it is 1 minus t, differentiation of t is dt, minus t as it is, differentiation of 1 minus t, differentiation of 1 is 0, differentiation of minus t is minus dt, and that 2 whole divided by 1 minus t bracket square. And if you simplify, it comes as a divided by b. I think this is a dt first term, if you simplify the bracket, minus t dt plus t dt, and divided by 1 minus t its bracket square. So here you can notice that minus t dt plus t dt get cancelled, and the remaining is a divided by b dt divided by 1 minus t bracket square. Remember, in the examination, next example onwards, I am going to write directly the value of dx, and in examination or in while solving example, directly you can write dx is given by a divided by b dt divided by 1 minus t bracket square. Okay, now I will come to the limits. Now first I will write the given limits. Given limits, x is equal to 0 and x is equal to infinity. So what are the new limits for t? So again I will give 1 minute. Try to think on that and tell me the values. Yes, someone is completed. Yeah, here I will write that part. So in this substitution, if x is equal to 0, in this substitution, if you put x is equal to 0, then what is t? That is my question.
0.
Obviously, okay. Now you go in the reverse way. Now when you substitute x is equal to 0, this will simplify as a 0 is equal to at divided by 1 minus t. Now you simplify this equation, t you will get 0. Okay. Now next one, when you substitute x is equal to infinity, that left side becomes infinity, then what is t?
Infinity, sir.
Okay, one answer is infinity. Someone should talk on this. When this becomes infinity, for what value of t it becomes infinity? Now see, Atharva, I think you say infinity, na?
Yes, sir.
Okay, when you put infinity, na, that right side comes as mute. Infinity by infinity. I think you have studied that indeterminate form. Okay, when you substitute t as an infinity, na, right side, that comes as an infinity by infinity. It not works. It is indeterminate form. So it should be. Someone else. What will be the answer?
1.
Very good. It should be t is equal to 1. What happens? If t is equal to 1, t is equal to 1, what it simplifies? A divided by 0, and anything divided by 0 is infinity. Okay? And remember, what is our requirement? So this definition or this example, this statement we are converting to first definition of beta and limits required 0 to 1. That also you have to think. Accordingly you have to take. Okay? Now continue with that. Now next I required a plus bx factor, that also I will calculate. Consider a plus bx, that is a plus bx is given by at divided by 1 minus t, and if you simplify by taking cross multiplication, that denominator will come as a 1 minus t, and by taking cross multiplication it comes as a minus at and plus at, and again here minus at plus at get cancelled, so it comes as a divided by 1 minus t. But in the integrand I required reciprocal of this, that's why I will take reciprocal on both sides. So 1 upon a plus bx is given by 1 minus t divided by a. Now little bit I will scroll screen up. Okay, this much is fine. Control, yeah. Now thus the integral I will write. After that I will scroll. I is equal to, what are the new limits? 0 to 1. What are the new limits? 0 to 1. So first I will write value of x. Value of x is a divided by b, t divided by 1 minus t, its whole bracket raised to m minus 1. Is it right? After that 1 upon a plus bx, that you have calculated. 1 minus t divided by a, that whole raised to, what is that power? M plus n. And that dx you have calculated a divided by b dt divided by 1 minus t its bracket square. Now I will scroll, only I have to simplify. Now what I will do, from this integral a divided by b I will take outside. Now I will write the effective power. A is in the numerator, that's why m minus 1. Now a is in the denominator, you have to change the sign, minus m minus n. A is in the numerator, plus 1. Okay. Now b is in the denominator and I am writing in the denominator only m minus 1, and here plus 1. Only 2 terms. And the remaining integral is 0 to 1. Again collect t and 1 minus t term. So how many terms are there containing t? I think only one. Only one. Now this one. Okay. What is it power? Its power is m minus 1. Now next you have to collect the effective power of n minus t. You have to collect effective power of n minus t. So remember the factor 1 minus t you are writing in the numerator. So that's why while writing the first power you have to change the sign. Okay, you have to take the reciprocal. That comes as a minus m plus 1. Now in the second, that 1 minus t with that power is in the numerator, that remains same. Plus m plus n. And the last one minus 2 is in the denominator. So make me correct if I am wrong. As per our requirement, both terms we have to write in the denominator, I think. So here for b raised to plus 1 minus m get cancelled, it is b raised to m. And for a, minus m plus m minus 1 plus 1 get cancelled. And that a term I am writing in the numerator. But in the next step, I am writing in the denominator, and in the first step, it is a negative power. And when I write in the denominator, it comes as a positive power. Okay. And the remaining is integral 0 to 1. First one is t raised to m minus 1 into 1 minus t raised to. Now again see, I think minus m plus m get cancelled. Plus n and minus 1. And that is nothing but the beta 1 upon a raised to m b raised to m into beta of mn. That is the required answer. I think that same thing we have to prove here. That same thing we have to prove. Okay. Now note that we consider as a third definition of beta function. Note that we treat as third definition of beta function. So what you have to do, third definition of beta function, put a is equal to b is equal to 1 in the above example. In the above example, then what you will get? First I will write the integral. I think that statement is with you. Anyone can help me to write. So the integral is given as 0 to infinity x raised to m minus 1 divided by both a and b. You have to put 1. Then that factor becomes 1 plus x raised to m plus n dx. And for the right side, that I will write to the left here. 1 upon 1 raised to something, that result here only I have written. That is nothing but only simply beta of mn. And this we consider as third definition of beta function. So I will advise, if the separate numericals are there and maximum marks are given, in that case, so try to prove by using the substitution. Okay, don't use directly standard results. If you are using that, also okay, but depending on the length and marks, you have to decide. Okay, so next example, I think third or fourth, fifth example. So one example I will take on this type. Fifth example, evaluate integral 0 to infinity root x divided by 4 plus 12x plus 9x square dx. Yes, anyone can tell. So what I have to do here? What I have to do?
Sir, in denominator, we have to find the roots.
We have to find the
It's a
roots or
quadratic equation.
try to find the factors. Okay, same thing. So first one, suppose I is equal to integral 0 to infinity. I will write it as root x divided by 4 plus 12x plus 9x square. The same thing I will write integral 0 to infinity root x is nothing but x raised to 1/2. Can you tell orally the factors? Now check it. Check it. Check it. Check it. I will give 1 or 2 minutes. So try to identify. So it is a perfect square, 2 plus 3x bracket square. If you write in the perfect square, then what is the substitution? So recall the first one. Put 3x is equal to, means bx is equal to 80 divided by what is the term? Yes, bx is equal to 80 divided by, where is that? 1 minus t. I think that bracket are written correct, na? Hello?
Yes, sir.
Okay. So x is equal to 2 by 3 t divided by 1 minus t. That is your substitution. That is your substitution. Then what happened? So here you have to write dx. So first example only I told that don't calculate. So in this case dx I will write directly as 2 by 3 into dt divided by 1 minus t its bracket square. And the limits, given limits for x 0 to infinity, new limits for t from 0 to 1. Okay. Okay. So again I have to calculate the factor 2 plus 3x. Now this 2 plus 3x is given by 2 plus 3x is given by 2t divided by 1 minus t. If you simplify, the denominator is 1 minus t and the numerator is 2 minus 2t plus 2t. It comes as 2 divided by 1 minus t. So anyone confirm I am audible now? Voice is coming now?
Yes, sir.
Okay. Now, so this integral can be written as, now purposely when I am writing now, thus means that break is there. In between you have to write these steps, right side temp. So the new limits are from 0 to 1. New limits are from 0 to 1. X is, in this case your x is 2 by 3 into t divided by 1 minus t its whole raised to m minus 1. It whole raised to m minus 1, and 2 plus 3x is 2 plus 3x is, but I have to put its reciprocal. Remember I have to put its reciprocal 1 minus t. I think something I made mistake. I will correct it. Anyone can rectify it? Anyone can rectify?
Raised to 1 by 2.
Yeah, raised to 1 by 2. It is raised to 1 by 2. It is raised to 2 because already I have taken reciprocal, and dx is nothing but dt into 1 minus t bracket square. Now from this I will take 2 by 3 as outside, integral 0 to 1. So 2 raised to 1 by 2 minus 2. So anything comes again?
So dx 2 upon 3 t upon t minus 1.
Yes, I forgot to write 2 by 3, means again I have to take plus 1, right now? Very good, thank you. And next 3 raised to 1 by 2 and plus 1. Now remaining is t and 1 minus t term. Can anyone tell directly the power? Okay, there is a single term of t every time. Now here 1 minus t is minus 1 half plus 2 minus 2. Is it okay? Whatever power I have written, that is correct? Aaya na?
Yes, sir.
Okay, 0 to 1. I think this is a, this term I will write as a 3 root 3. 3 raised to 3 by 2. And the 2 raised to, what it will come? I think root 2 only. Because that power is 1 half minus 1. It comes as minus 1 half. Okay, one note will close. Meanwhile, you complete that example. Okay, 0 to 1, t raised to 1 by 2 and 1 minus t raised to minus 1 by 2. So confirm the steps because my calculations may be wrong. Yes, anyone can confirm whatever I written, it is correct.
Yes, sir.
Okay. So it can be written as further 1 upon 3 into root of 6. And here you have to make the adjustment. This I will write beta of plus 1 minus 1 plus 1 minus 1, and it comes as first parameter and it comes as second parameter. Okay. So it comes as a beta of 3 by 2 and what is the second? 1 by 2. Beta of 3 by 2 into 1 by 2. Okay. Now further, suppose if you are simplifying, it can be written as 1 upon 3 into root 6. Why it is coming something here? 1 upon. So it comes as a gamma of 3 by 2 into gamma of 1 by 2 divided by, what is the term? Gamma of 3 plus 1 is 4, divided by 2 is 2. So further it is 1 upon 3 root 6 into gamma 3 by 2 can be written as 1 half gamma 1 half. So this gamma 1 half as it is, and gamma 2 is nothing but 1 factorial. Further it can be written as pi upon these two terms together, 1 upon 2 and 1 upon 3, it comes as a 6. Root 6. Verify someone. You are also getting
Yes,
same?
sir.
Okay, fine then. Thus, the evaluation of the integral I is equal to pi upon 6 root 6. So, one similar example I will give for the homework. Okay. Next number you may continue 6th one. This you complete as a homework. 6th. Prove that integral 0 to infinity x raised to m minus 1 plus x raised to n minus 1 divided by 1 plus x raised to m plus n dx is given as 2 times of beta mn. Only I will explain the steps here. So this example, complete steps you have to complete as a homework. I will explain the steps. Suppose first I will call this integral as a I. So first I will call this integral as a I. So let I is equal to integral from 0 to infinity x raised to m minus 1 plus x raised to n minus 1 divided by 1 plus x raised to m plus n dx. So what I will do, by linearity property, I will write this integral as a sum of 2. Integral 0 to infinity x raised to m minus 1 divided by 1 plus x raised to m plus n dx plus integral 0 to infinity x raised to n minus 1 divided by 1 plus x raised to m plus n. And suppose this I will call as sum of the two integral I1 plus I2, and suppose this equation as number 1. So where, what is your I1? This I1 is nothing but integral 0 to infinity x raised to m minus 1 divided by 1 plus x raised to m plus n dx. So this integral you have to complete and it will come as a beta mn. So what is your substitution? So to prove this, you have to put x is equal to t divided by 1 minus t. Okay. So this example you have to write a solution in detail. You have to write a solution in detail. Now in the same manner, similarly, second integral don't evaluate. So you have to change the role of m and n in the integral 1. Integral 0 to 1 infinity x raised to n minus 1 divided by 1 plus x raised to m plus n dx. Now it will come as a beta of nm. Is it okay? But we know the property that beta of mn and beta of nm both are equal. So it will it can be written as beta of mn. Therefore, that equation 2 becomes, therefore, that equation 1, not 2. Equation 2 becomes I is equal to beta of Mn and beta of Mn. It comes as a 2 times beta of Mn, and that is the required answer. So again, I am telling, suppose this example is asked for 7 to 8 marks. You have to write solution for this integral. You have to prove this. This first integral you have to prove, and for the second integral you can use similarly by changing the role of m and n. Second integral can be evaluated as a beta of mn. Okay. So again, we have to discuss some more examples. Today I will try to complete the beta function.